Alright, hello people of the internet. Welcome to another edition of Real World Networking. Since you hopefully watched the last video on ticket number 1 where we dealt with port security, I've been pretty busy at work, and I'm also been on the on-call rotation a lot of times. Since we're talking about real world networking, when you get a job as an admin or an engineer, there's a chance you're going to end up in an on-call rotation where you get called in if there's outages or something that needs to be fixed. So I've fallen victim to that. That's always a good time. Luckily, it's just a rotation. I see it a lot when you work in a knock environment. There's a chance you could work shifts too. Even more so than just on-call. You could actually work, say, weekend shifts that are outside of your normal schedule. So that's something to keep in mind, especially as you're getting into the entry-level networking, is that your individual experience may vary depending on what kind of a role you take on. Not as often in an engineering role are you picking up random shifts. I guess it depends on where you work. But there's usually always an on-call just in case something needs to be escalated to you. So the reason I tell you that is, one, just for job role understanding, but two, because I haven't made too much progress in moving over and kind of upgrading the process we're using here. I haven't been able to install a web-based ticketing system yet. I tried one, but it seems like maybe the developer stopped working on it because I was getting some issues between PHP and MySQL. I got a local LAMP server set up here. I also, yeah, it is. It's running on Ubuntu on my ESX server. I also put it on an actual web host and it failed out, so that one must be no good. So short of making my own, I'm still looking for a solution for that. So for this example here, we're not going to use a ticket, and sometimes you don't have tickets anyway when you're in your day-to-day functions. In fact, I hate to say it, but a lot of people will try and come up to you or call you and ask you for favors, if you will. Usually people that are also in IT, maybe in a different section, such as servers or something. They're just hoping you'll help them out, so they'll help you out if you have issues, or if you need, say, a new VM spun up for an operating system that deals with networking or voice, maybe a Cisco call manager server. So it's really on your own methods on how you handle those drive-bys, we like to call them. You can force everybody to a ticketing system, and that helps with metrics and tracking, especially if you get busy out of nowhere. With a lot of those kind of drive-bys, or if times are slow, you can help them out, or if it's a high, like an emergency situation that something needs to get done. But a lot of things that require changes usually have to go through some sort of a change management process where you have to get it approved, and a lot of times changes can't be made on production equipment throughout the day. We're going to throw that last bit out the window for this process here. We'll just assume that we've already gone through change management and it was immediately authorized. So you understand what we're dealing with. Let me switch over. Here's GNS3. Let me move this over a little bit. I switched over from Packet Tracer. A lot of you mentioned that some of the command line issues I ran into with Packet Tracer, for example, you were not able to do something like show run int f0/0, which is typically how I would look at a configuration for an interface. A lot of that will be defeated by moving over to GNS3. GNS3, I'm using the early release copy if I booted the right version here, because they don't install over each other, which is strange, I thought. But anyway, there's definitely still a lot of bugs. In fact, I can show you right now with this example. If I move a new router out right now, you can see it's not showing up in my topology summary. I can't boot this thing. I can't change the symbol. Nothing's loading. GNS3 has kind of a server-esque backend. I don't know exactly how it functions, to be completely honest with you, but I do know that they've mentioned, obviously, that there's still ongoing bug kind of identification and mitigation with the new early release copy, but is to be expected. So you'll see some switches on here. No, we did not figure out switching yet on GNS3. I know that it uses an IOU method, and you have to kind of boot the special IO, or it is essentially a Cisco iOS. You boot it into a Linux distro, but the release of that software at least back when it was internal to Cisco use only. Apparently it was very limited and not supposed to be released to the public at all. So GNS3, I believe, is supposed to be getting hopefully a hold of something like that and pushing it out to the users before early release goes public. Because right now, I mean, they integrated it, but if you don't have the IOU for that, then you're kind of hosed. And I know there's ways you can acquire it, but I'm not going to go through that for something that I'm putting on YouTube here. So we'll work with what we got. What we were able to do back before it froze up was change the symbol. Oh, wow. So the ones that are already in my topology, I don't know why it's doing that. Earlier it locked up and I tried to save the lab and it corrupted out, and I had to redo the whole thing from scratch. So it's a little less, there's not as much on this topology as when I did it the first time. But anyway, we changed the icons here to make them look like layer 3 switches. And when you add the switching module into the routers on GNS3, into the slots, so I have just a 16-port switching module right now, a lot of the functionality is there. There's certain things that are different, but obviously this is kind of the old school GNS switching capability. It's not real switching. That's why they're moving forward with the IOU, as I said, but we already covered all that. So here's all that rambling on just to bring you up to speed, and I am going to do another video as well on kind of just some various topics. It's going to be a real short one, just kind of real world networking things I've run into recently that you can keep in mind for. Anyone that's maybe doesn't already have a job as a network admin, network engineer, give you an idea of what to expect on the day-to-day, more so than these hands-on labs, or probably less so, but it's just different. It's a different view, and I'm not going to do anything hands-on with those. Here's what we got. All right, we've got a core switch here. That's where all of our SVIs are for the LAN segment. The LAN switch at building 01 has an Ethernet, or a trunk rather, back up to the core switch. So we've got VTP set up, a domain running, and the VLANs are being pumped down to building 01 from up here, which hosts the SVIs. So hosts that are hooked up to these VLANs, ports that are assigned to those VLANs, they'll come back over to the core 01 switch. Disregard the names above. I need to figure out how to turn that off too. I forgot before I started recording, so we're running with it. They'll come up to core 01 for their actual gateway. So the request that we received was a new server stand-up. You can see this server over here titled R1, so be it. This is actually a router also with the symbol changed. I spun up some VirtualBox OSs, but it was just bogging this system. So another thing I found, a deficiency that I need to work on here. Servers are getting pretty sophisticated these days. We'll pretend that this is a SCCM server, which can push updates and can do Pixie booting, which is like loading an operating system over the LAN. They're sophisticated in the extent that there's a lot of features they have. They have things like ILO now, integrated lights out, where you can remote into the server and power it on if it's powered off. They have dual NICs, or sometimes not even dual. They have a lot of NICs on some of these servers, and the capability to do their own .1Q tagging. So actually, SCCM is a bad example. Let's do an ESX server that should deal with .1Q tagging. So the reason .1Q tagging is important is because this server can tag its packets as it sends them out. And so when they come into the switch, the server essentially has already put them into a VLAN. Kind of like the Cisco IP phones have the ability to do the voice and data VLAN. Similar, a little different. But so they have on this, the server guy that came through told us that he has 2 network interfaces that he wants us to plug into. And he'd like us to set up a new VLAN for this server as well. So we need to get that propagating through the network. We've already got a server VLAN 50 and Exchange VLAN 51. We're going to make a new VLAN for the ESX servers. We're going to call it ESX. We'll call it VLAN 52. That'll work for now. So VLAN 52, we're going to go over to our IP management Excel sheet. Typically you'll have software in a good environment. Info blocks, or I'm not sure if SolarWinds has their own spin-off derivative. There's a lot of commercial software out there that does nothing but IP management. So this is where you'll come and see what subnets you already have in use and what you have free to carve away from. So we're going to take the next available from this area here. We're going to go 52.0. We'll make it a /29 as well. No, we won't. Outstanding. That's this is a feature of Excel called the freeze up while I try and figure out if you want to type a algorithm. Alright, we'll make it a /29. We'll call it ESX. I'm not even going to put in the rest. This is bad. I think I bogged this machine down earlier. It's just a little laptop that I'm using for recording this copy here. I bogged it down earlier with the VMs and everything running on it. But alright, so 10.0.52.0, and it's a /29, which is a 248, I believe. Yeah, 248. And so first thing we're going to do is go into the server switch. We're going to here's another thing. Immediately off the bat, I like GNS3 better because I can do if I'm in config T mode. But let's do show IP in brief. Do allows you to run commands when you're at the configure terminal mode. Let's use fast10 and fast11. Those are two of the I showed you earlier, the 16 port switching interface. So let's control C out of that. Let's go int fast10. Let's give them descriptions. ES6 serve1. Let's actually, I probably should have notepadded this, and then you can just copy and paste it all into the next interface. But I might be able to up arrow anyway. So description, yeah. All right. So let's do switchport trunk encapsulation .1q, and let's do switchport mode trunk. That should be enough to get us going here. So what we're doing is the two connected interfaces go into that server. We're going to actually make them an ether channel. That server's capable of that as well. And the ether channel provides kind of load balancing, if you will, and it kind of increases the throughput. So if you have, these are fast Ethernet, so these are only 100 meg connections, capable of up to 100 meg. By using two, it gives us up to 200 meg. All right. So in a real environment, your server, you're going to want as much throughput as you can, especially if you have a lot of users utilizing the services it provides. So you're more than likely going to use more like a gig interface or a 10 gig interface, and maybe EtherChannel, a couple of those together. For the purposes of this, we'll just run 200 megs together. So we already made fast10 a trunk and described it. And descriptions will save you as you're looking through what you have going on in the network. And we can up arrow. Outstanding. Saved server, so we're going to do the same description here. Encapsulation.1q, and let's make it a trunk. If you ever get an error saying you can't do encapsulation.1q, it means it probably doesn't support anything else, so you can just at that point do switchboard mode trunk. But a lot of times when you do mode trunk, it'll complain about encapsulation being specified first, so that's why I'm doing that, even though I know I don't have to on this particular device. Alright, so we have two interfaces, F0 or F10 and F11, that are ready to go. Next thing you need to do for this this port channel, or this ether channel if you will, is create the port channel itself. So we're going to do int port channel 1. We are going to do well, that was silly of me. We'll back up to that. Fast10 and fast11 we have to put into this port channel, but that's fine. We'll configure this thing first. So we're going to do the same exact commands we just did a minute ago. Switch port trunk encapsulation .1q, switch port mode trunk, and that should be good to establish a trunk. Now you would want to do something like switch port trunk and allowed VLAN, and then include the VLANs that the server is intending to run on. So it's VLAN 52, and we already cut out the IP address space for it, because they're going to assign themselves an IP address, and when they send packets out over that VLAN, it's going to come across what they have tagged, and you have to have that allowed over your trunk. By default, trunks allow all VLANs. Typically, you want to knock off the VLANs that aren't needed and only allow the ones that are in play for security purposes and efficiency. Also, VLAN trunking protocol should knock out VLANs that it knows are not currently active there, so it's not going to pump all VLAN traffic for no reason down there if there's no devices that are using that VLAN. So hope you're following on all that. We're not going to worry about the allowed VLANs for now. We're going to let it run, and I'll show you in a minute what that's all about. So we have the port channel, we have the interfaces. The thing we have to do is we have to go back into the interfaces and assign them to that port channel or that ether channel. So the thing we have to do now. You know what? We can range this too. Thank God we're in GNS3. We probably wouldn't be able to do this in. Well, we might have been able to in Packet Tracer, but anyway, we can do int range f1/0 through 1. Now we're into both of those interfaces at the same time, and we're going to do. All right, I had a brain meltdown there for a second, but so you want to do a channel group. The wording changes between all these: port channel, ether channel, channel group. So you just have to keep that in mind as you're configuring various things. But so you want to do a channel group, and we're going to do 1. That number there, 1, specifies which port channel. So that port channel 1 we just configured, we're assigning these interfaces to that port channel. Mode is the next command you're going to do, and then there's a couple of different options you have at this point. Oh, just kidding. Well, okay. So I guess this I didn't test this out prior, but typically when you after mode you have a couple different options which specify if you want to use LAGP or LACP, PAGP or LACP. I'm not sure what I said there. Those are two different EtherChannel protocols, if you will, and they have various features to them. Typically we use LACP, so I guess GNS3 only has one option. So that is it. If you do a show EtherChannel, I think we can specify which one, or you can do summary. Alright, so you can see fast 1, 0 and fast 1, 1 are now in the ether channel, which is PL1, port channel 1. We assign them to that with channel group 1 mode on. As I said before, you have active, passive, a couple other different options when you're actually working with a full-blown switch iOS. So there's some information you can see in the show EtherChannel summary as far as what the status of each port is. So that can help with troubleshooting issues if maybe you have one GBIC interface go down or something, then you can see kind of what it is. But you probably see the interface go down too. So take it as you will. That's just a command there for your capabilities. So just to show you again what the actual interface looks like, there's not much to it. Just match up what mode it is and any other kind of configuration options with what you have in the port channel 1. Show run in port channel 1. Description obviously doesn't have to match, and then in the interfaces themselves you have to assign them to the channel group, and that's all there is to it at this point. Let's physically cable it up. Again, this server is a actual router, but for the purposes of this lab it'll make do. Because it is a router, though, we may see some weird things happen here, but we'll see what it shows. Let me move this over to where you can see it again. Show EtherChannel 1 sum. Showing 1, 0 as being down still. Showing status include 1, 0. Not connected. Conf T in F1, 0. Shut, no shut. Join port channel, change state to up. Let's see if it shows it now. Show in status I10 says connected. So let's do show EtherChannel 1 summary. Alright, so you can see P. Both of those ports are now in the port channel. So at this point the server team is going to configure their NIC accordingly as far as what VLANs they're running over that port channel, and they'll also, their server will be aware that it's a port channel. So with that essentially takes care of half the issue, a big chunk of it really, and there wasn't too much to configure. The other half would be their new subnet, 51, 52, 52. So we need to make a new VLAN over here on the server router. Oh, I was just in there. We're not going to leave the server router. I should realize that. Oh, we will for a second here. Okay, so what we are going to do is go into configure terminal, make a new VLAN. This is referred to as an SVI when you go into a layer 3 VLAN here. You have the layer 2 where you just do VLAN whatever, or sometimes you still have to go into VLAN database and do whatever. The layer 3 though is where you can assign an IP address to that VLAN. Typically this is where you're going to make the gateway of any devices connecting into that VLAN. So we are going to give it an IP address of 10. I forget, and this Excel sheet's going to freeze up again. 10.0.52.0. So we're going to make 52.1 is the first usable. 255, 255, 248 if I remember right. You shouldn't really have to no-shut a VLAN. Let's call it description, ESX, VLAN. That'll work for me. We should probably make sure we have the layer 2, VLAN 51. No, we don't. So we need to build that. Typically when you add a port to a VLAN, it'll build it. But when you're using trunks, it's a little weird, a little different. So let's do, because when you use a trunk, you don't actually see it assigned to that VLAN typically. So let's do VLAN database. This is kind of the, I think this is the depreciated method. Typically, I think you can just do VLAN 10 from the configure terminal mode, but I know with these routers, they're not actual switches in GNS3. So let's do VLAN 51 name ESX VLAN. So now if you do a, typically you do a show switch brief, or I'm sorry, show VLAN brief on a switch, but show VLAN-SW is how you see VLANs on a router. Any router that has a switching module, that's what you're going to do. So you can see VLAN 51 there now. Let's do show int trunk, see what's coming over that VLAN. Allowed and active VLAN 51 is coming over that port channel. So that should so let's make sure that VLAN came up. Showing up. Oh geez, how long have you been watching, seeing what I was doing and calling me special? Do I want to? Yeah, I probably should. What did we make the layer 2? VLAN 51 also? Yep. Oh my god. Alright. And we're back. Alright, I made some adjustments here. So, undid the damage that I did. You can see that we have, I also added the layer 2 for the other two VLANs. We have the ESX VLAN now on 52. Show run int VLAN 52 shows us our layer 3, our SVI. And that is correct now as well. Show int trunk is now probably going to show on our one trunk all the VLANs, yeah, because the layer 2 is there for all of them. And like I said, we didn't specify what VLANs are going across this ether channel here, so that's fine. We'll just run with that. The only thing we have to do now, the last thing we have to do, is add that network to EIGRP. So if you do show run, actually, yeah, section router EIGRP, I believe you can do that. That should work fine if GNS allows it and figures out what I want from it, or locks up. Okay, there we go. So we're gonna go router EIGRP 10. We're gonna do network 10.0.52.0 0.0.0. It was 248.7, and that should be it. We should be broadcasting that network now through EIGRP. Let's check on the neighbor, the core switch, because keep in mind this is again a layer 3 connection there. So on the core switch, let's do a show IP route. And there it is. I've got no auto summary on, so you can see all three of those 50 networks, or it probably would have super netted them there. But so 10.0.52.0, there it is. So network can now pass over and go over that trunk to the server. At this point, server team configures their NIC and their server to work with the EtherChannel, and they are good to go. Server's up and running. So a couple of hiccups in this video. As I've said, this is video number 2. I'm still kind of dialing in a few things, and this is the first video we've done in GNS3, so I'm looking to improve in the upcoming videos. We will go ahead and leave comments on anything that you'd like to see in future videos. I know there's still the working towards getting kind of a over the internet VPN connection set up, so the users that have gotten a hold of me offering connections to their lab equipment, I'm still looking to message you back in the coming days. I just wanted to set up another quick and easy one this weekend, as I kind of got things set up for hopefully better quality of videos moving forward. But hopefully you took something out of all this rambling and kind of, I know I'm jumping around all over. That's another thing that was identified as a weakness, is I kind of need to have a battle plan here for moving along through the video as far as staying on topic. But I kind of like it as well, though, being able to ramble, because I get to give you little odds and ends that maybe if you're not familiar with networking, it gives you a little insight as to why or what. So that is it. That's all I got for you in this video. Leave comments. Let me know what you think. Again, we're still kind of in rough production phase, so hopefully it'll get better as we go.